Today, we'll build a system to monitor and control an ESP32 from anywhere, without dealing with port forwarding or exposing your home network. We will use MQTT and the free cloud broker as a secure bridge between your devices. I will guide you step by step through the entire setup. Just follow along, and by the end you will have a working system that lets you monitor and control your ESP32 from anywhere. Here you see the whole system. On the left side you see the sensor node with an ESP32, an AH10 humidity and temperature sensor and an LED. The sensor node is at a remote location, let's say the office. On the right side is the ESP32 display node, which is an ESP32 serving a web page which you can view with any phone, laptop or tablet connected to the Wi-Fi network. You can also directly access the system in a browser without an additional ESP32. I will explain this later in this video. The display node is at another location, in my case at home. In the middle we have the HiveMQ cloud, which is a free MQTT broker that can receive and send MQTT data messages. The sensor node will read the AH10 sensor every minute and send an MQTT message via the office Wi-Fi connection to the HiveMQTT broker. When the broker receives the message, it will forward it to the display node at home, which is listening to the HiveMQTT broker. The display node will receive the message and display the data on the local web page server at home so you can see it in your browser on your phone, laptop or tablet. The communication is bidirectional. The web page has a button switch to control the LED at the office. If you toggle the button, the display node ESP32 will send an MQTT message to the MQTT broker, which will then relay the message to the office sensor node, which will switch the LED connected to GPIO8 on or off. For the demonstration, I use ESP32 S2s, but this can work with any ESP32 device, and you can always add more switches and sensors to the system. You can also add more display, sensor nodes and more locations. Now let's get started and set up this system. We will set up the system in 5 steps. First, we will set up the HiveMQ cloud broker. Then we will test the cloud broker with MQTT Explorer. Then we will build the ESP32 sensor node and flash the software. Then we will test and verify that our ESP32 sensor node is working with MQTT Explorer. Finally, we will set up the ESP32 server, the second ESP, the display node. Now let's start to set up the HiveMQ cloud broker. First, go to hivemq.com and create a new free account. You can use Google, GitHub or email. I already did it, I used Google, so I will just log in. Click on Cloud Clusters. Create a new cluster. Here, select Create Serverless Cluster. Then click on Manage Cluster. Go to Access Management and at Credentials click Edit. And I need to scroll down. Click Add Credentials. Here you need to select a username for the cloud cluster. So for the username I say Design Graveyard. Password is secret. And for the option, click Publish and Subscribe. Click Save. We go back to the overview. We will use this URL in the Arduino code to connect to the MQTT broker. This is the MQTT broker port. If you go down, here you see the same link with the port behind it. This is the TLS WebSocket URL. That is to access MQTT directly from HTML JavaScript. We will not use this. Now copy this URL and create a text file and save the URL. Your username, and your cluster password. And save it. We will later use this information in the Arduino code. HiveMQ is free. It is limited to 100 devices and 10 GB of data per month. This is more than enough for a hobby project. EMQX Cloud is another alternative, but I did not try that. Now let's test our HiveMQ MQTT broker. To test your HiveMQ broker, we will use MQTT Explorer, so you do not need an ESP32 or any code to verify that it works. Download MQTT Explorer at mqttexplorer.com. It is available for Windows, Linux and Mac. Start MQTT Explorer and open the text file with your HiveMQ cluster data. Click plus for a new connection. Let's call it HiveMQ. Protocol is MQTT. Then copy the URL, your username, and enter the password. The port needs to be changed to 8883 and encryption must be on. Click Save and click Connect. Now we are ready to test. At the topic here, type Office Sensor Temperature. We click Roll and say 25.34 degrees. Publish. Now on the left you see a message appeared. Click to expand and you see on topic temperature the value appeared. This information was sent to the HiveMQ cloud and retrieved by the MQTT Explorer. Great, this works. Now we will let the ESP32s send and receive messages to the HiveMQ cloud. Let's go to the next step and build the ESP32 Sensor Node. To build the sensor node here on the left, we will connect a AHT10 sensor and an LED to an ESP32. I use an ESP32 S2 Mini. Other ESP32s will also work. I like the S2 Mini because it is inexpensive and quite reliable. I tried the C3 Super Mini, but the Wi-Fi performance was really bad. If you have any experience with the C3, please let me know in the comments. Connect the LED with a 220 ohm resistor to GPIO 7 and the negative side to ground. Connect the AHT10 sensor to 3.3 volt, ground, and connect the I2C pins as shown here. SCL to pin 9 and SDA to pin 11. Your sensor node is ready. Let's open the Arduino IDE and have a look at the software code. Here you see the code of the sensor node in the Arduino IDE. Let me walk you through it. In line 8 and 9 there are two libraries which you need to install. The Adafruit AHTX for the sensor and PubSub client for MQTT. In lines 15 and 16 you enter your Wi-Fi information and here you enter your HiveMQ cloud credentials. The URL that you created, the port is always 8883, your HiveMQ cluster username and your HiveMQ cluster password. These are the MQTT topics which are used in this code: temperature, humidity and the LED control. The onboard LED is 15 for an ESP32 S2 Mini. If you use another ESP32, you may need to change that. The remote LED we will control with MQTT is connected to GPIO 7. The sensor data is published every 30 seconds. Here we check for MQTT messages. This is a unique client ID. Every ESP32 connected to the same HiveMQ cluster must have another client ID, so make it unique. Here we connect to HiveMQ. Here we publish the sensor data, the temperature and the humidity. Before uploading, if you use a ESP32 with on-chip USB, make sure USB CDC on boot is enabled. Otherwise your serial monitor will not work. Now we can upload this code and let's start Serial Monitor and the MQTT Explorer to see how it works. We connect to HiveMQ and here you see the ESP32. So we are connected. The temperature and humidity have been published. And we see the same values here in the MQTT Explorer. Now let's try to control the LED. Office LED control. Let's publish A1. You see the LED is on and the message has been received. Turn it to 0. The LED is off and the message is received. Great, this works. Now let's go to the next step, the display node. We can now control and read the sensor node with MQTT Explorer. So the most complicated part of our system is working. The only thing left to do is to create a nice user interface for it. We can achieve this in two ways. We can use a second ESP32, which serves a local HTML web page, or we can directly control it from a browser. Let's start with the ESP32 server method. For this, we only need an ESP32, some software code and a Wi-Fi connection. Let's open the Arduino IDE and see how that works. Here you see the code in the Arduino IDE. You already have all the libraries you need, and here you enter your Wi-Fi network information. Now the web page will be at a fixed IP address, in this case 192.168.1.224. To see the interface, you just type that IP address in your browser. This IP address range is very common for Wi-Fi routers. However, in your case it may be different. To check that, in Windows, open the command prompt and type ipconfig. Here you see the IP address of this computer, 192.168.159. The last number is unique for each device in your home network. Normally, numbers between 200 and 250 will be available, so I use 224. These three first numbers can be different. For instance, for my phone hotspot, it is 172.20.10. Here we have again the HiveMQ cluster URL, the port, username, and the password. We have the same MQTT topics, and this part is the HTML web page. This is AI generated. You can use your favorite AI chatbot to change the look and feel. The rest of the code is very similar to the sensor node. Now let's upload the code and see how it works. I uploaded the code to a second ESP32 and you see here the sensor node running. I have my computer and the phone connected to the same Wi-Fi as the display node. Here you see the IP address in the browser and I type the same address in my phone. We can read the sensor data and we can control the LED with the switch. Now we can read out and control the sensor node remotely. And we have a nice user interface. Finally, I will show you how you can make the link directly in a browser. The HiveMQ server also allows MQTT control via Websockets. This enables us to directly send and receive MQTT messages with HTML and JavaScript code without an additional ESP32 server. So no Arduino, just an HTML file. And you see, you can control the LED and also receive the sensor data. Now this works different from Arduino code, and as an electronics designer, I am really not an expert on this. However, with some help from DeepSeek, I got this running. Let me walk you through the code. This link here is the most important part of the code. It loads an API or an application programming interface which explains to your browser how MQTT works. Now if we scroll down, we have again the same HiveMQ cluster URL, username and password which we used before in the Arduino C++ code. There are two differences. It starts with WSS and the port is now 8884 instead of 8883. All logic and timings are now handled in JavaScript. No need for an Arduino or the Arduino IDE. Just save this file as .html and open it directly in a browser. And make sure that you have your sensor somewhere connected and running. Now we can receive the sensor data and control the LED directly from the browser from anywhere. It also works with smartphones, but Apple does not allow you to create a shortcut on your home screen because of safety reasons. If you can imagine any other reasons, please let me know in the comments. I hope you liked the video. If it was useful for you, please like and subscribe, and let me know your experiences in the comments.